This study examines the determinants of emigration from the Western Balkans to major European destinations using a gravity model framework for the period 2014 until 2023. The analysis identifies key economic, demographic, and institutional factors influencing migration flows, including GDP per capita, population size, and labor market conditions. International migration has long been a key aspect of demographic, economic, and social transformations, influencing both origin and destination countries. In recent years, immigration from the Western Balkans has emerged as a significant phenomenon driven by a combination of economic disparities, labor market conditions, political instability, and social factors. The region, which includes Albania, Bosnia and Herzegovina, Kosovo, Montenegro, North Macedonia, and Serbia, has experienced sustained immigration flows, primarily toward Western European countries. This immigration patterns are shaped by historical ties, EU integration process, and economic opportunities abroad. Understanding the drivers of immigration from the Western Balkan is crucial for designing policies that address both of challenges and opportunities associated with migration. To analyze these migration flows, this study employs the gravity model, a widely used framework in migration economics. Originally developed to explain international trade patterns, the gravity model has been successfully adapted to migration studies, demonstrating its robustness in explaining bilateral migration flows. The gravity model, initially defined to explain international trade flows, has become a pivotal tool in understanding migration flows between regions, countries, and territories. Rooted in Newton physics, the model states that the interaction between two entities is directly proportional to their economic sizes and inversely proportional to the bilateral size separating them. This framework has been extensively adapted to identify, analyze, and forecast migration patterns, offering insights into the factors influencing human mobility. The gravity model's conceptual foundation lies in Newton's law of universal gravitation, which states that the force between two specific objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. In the context of trade or international trade, this translates to the idea that larger economies have a greater pull on trade flows, while greater distances diminish these interactions. Jan Tinderberg was among the first to formalize this analogy in economics, proposing that bilateral trade flows could be predicted based on the economic sizes of two countries and the respective bilateral distance. Tinderberg formulation suggested that the volume of trade between two countries is directly proportional to their gross domestic products and inversely proportional to the distance separating them. Recognizing the model's very high explanatory power in trade, researchers began applying the gravity framework to migration studies. Larger populations generate more migrants, and the propensity to migrate decreases with increasing distance. The model states that migration between two countries or regions is positively associated with the population sizes of both the origin and destination, and negatively associated with the distance between them. This approach has been instrumental in identifying the quantifying the determinations of migration, including economic opportunities, cultural ties, and different policy factors. Recent research has expanded the model to include innovative independent variables such as cultural similarities, police environments, and historical ties. Groger and Hanson analyze how income differences influence international migration patterns, focusing on the role of income maximization in immigrants' decision making. Using a model framework, they find that higher earnings potential in destination countries is a primary driver of migration, particularly for skilled workers. Their study also highlights that migration costs and policy restrictions shape the selection and sorting of migrants. Overall, their finds suggests that economic initiatives play a crucial role in determining global migration flows. The gravity model continues to evolve with recent years studies analyzing its limitations and enhancing its forecasting capabilities. Is that traditional gravity models often fail to capture temporal dynamics in migration patterns. To address this, researchers have incorporated time-varying explanators and used advanced econometric techniques. For example, the use of long short-term memory approaches combined with real-time data sources such as Google Trends has improved the model's ability to forecast migrations flows. These innovations allow for more responsive and accurate model. The table provides a detailed overview of the variables utilized in our formulated and estimated model. The variables used in this study capture key determinants of migration flows and are sourced from official and reputable international databases. Migrate, representing migration stock, reflect the number of migrants from the origin country residing in the specific destination. Economic factors are measured through GDP per capita in origin and destination, where a higher GDP in destination country attracts migrants, while a higher GDP in origin may reduce immigration. Population in origin and destination accounts for migration supply and demand effects. The bilateral distance between countries acts as a deterrent due to associated costs. Unemployment rate difference reflects labor market imbalances, with higher unemployment in origin and lower in destination increases migration. Economic initiatives are further examined through wage differences. Education level differences reflects the difference in education levels between destination and origin countries. Political stability also plays a role, with political stability in the origin country, as individuals and families tend to live less safe environments. The equations have been estimated using a specific sample comprising Western Balkan migration stock in 20 European destinations over the period 2014 until 2023. The pooled ordinary least squares method was identified as the most appropriate estimation technique. The table presents the estimation results for the specified equations, both in their basics and extended form. The signs of the estimated coefficients align with theoretical expectations, and the parameters are statistically significant, thereby confirming the relevance of the considered migration determinants. The adjusted squared value, which accounts for the number of predictors in the model, is notably higher for the second equation, indicated that the explanatory variables explain a substantial proportion of the variability in the dependent variable. Unlike the standard squared, which may artificially increase with additional explanatory variables, the adjusted squared provides a more accurate measure of model fit by penalizing excessive predictors, ensuring that the included variables contribute magnificently to the explanation of migration trends. Additionally, the coefficient values are consistent with findings from similar previous analyses, reinforcing the robustness and validity of the estimated relationships. The findings of this study highlight the significant role of economic, demographic, and institutional factors in shaping migration flows from the Western Balkans to key European destinations. By employing a gravity model approach with research, confirms that GDP per capita, population size, and labor market conditions are key determinants influencing migration decisions. The empirical results align with theoretical expectations, demonstrating that higher economic opportunities in destination countries attract migrants, while adverse conditions in origin countries push individuals to seek better prospects abroad. The application of the pooled ordinary least squares method provided robust estimations, ensuring that the model effectively captures the relationship between migration and its driving factors. The high adjusted squared value in the extended model indicates that the explanatory variables account for a substantial proportion of the variation in migration flows, reinforcing the model's reliability. Furthermore, the estimated coefficients exhibit constancy with findings from prior studies, strengthening the validity of the analysis. Despite the robustness of the results, certain limitations should be acknowledged. The gravity model, while effective in explaining special patterns of migration, may not fully capture dynamic and policy-driven changes affecting migrant decisions.